Hi everyone, I'm Dr. Anil Shirahatti, Professor at Jain College of Engineering, Belgavi. So today we'll start with session 3 of Module 5, Manufacturing Control and Automation. So in today's session, I will be covering three topics. First one is the basic of part programming. Next is the preparation and miscellaneous functions, that is G code and M code. And then we will learn the importance of cutter compensation in milling operations. So let's start with first part program. So part programming is a set of instruction which instructs the machine tool about the processing steps to be performed for the manufacturing of the component. So we have given you a simple line of a part program. So you can see this is a part program line. It says N10, then G90, G01, X10, Y12.5, F100, S1200, T01, M03. So we will see each one by one. So what do you mean by N10? So this is the starting of the line of the part programming. Okay, so N10 is nothing but the sequence. Okay, nothing but you can say this will define. Okay, N10 is a line containing this program, this part of the program. Okay, then again I can have N20. This is the next line of the program. G 9091 are all preparatory functions. Okay, then the next one, what you see here, x10 and y12.5, that are the dimensions. What, so in this case I can say these are the coordinates given. F is nothing but the feed rate, so this is the feed rate given. S is nothing but the spindle speed, 1200, that is 1200 rpm is the spindle speed. Next, T01 is the tool function, so nothing but this is the tool number 01 I had to take from the machine. Next, miscellaneous function M03 is the next miscellaneous function. So M is for miscellaneous function, G is for preparatory function. In general, whenever whatever the G command is there, some function action will be taken. In this case, M03 will have like coolant on, coolant off. Okay, end of the program, all these stuffs. So let's see the programming format. So every program will start with uh, one program number, so which is given by percentage and O. Next is the n stand for the sequence of that block identification, or nothing but you can say in simple terms is a line number. So G is preparatory function, then x y z or u v w p q r all are the dimension in respect to x y and z directions. Similarly, r is nothing but here is a parameter, it may be a radius. Okay, f is the feed rate, s is the cutting speed, t or d is the tool number, m is the miscellaneous function, and eob is nothing but the end of the block. So what are these programming key letters? So you can see we got few key letters here. So O is for program number. So what it means is whenever any program number is given, it should start with O. So O 123 is my number, O 545, something like this. N is the sequence number, line number. So I can have N10, N20, next line number. G is the preparatory function. X is for designation towards X direction, Y towards Y direction, Z towards Z direction. R uh, is the alphabet or letter used for radius. F is used for feed rate. S is used for spindle. H is used for tool length offset designation. D is for tool radius offset designation. T is the tool designation. M is the miscellaneous functions. Next, let's see some of the important G codes. So all the G code will start with G. So G00 is nothing but a rapid transfers. G01 linear interpolation, Z02 circular interpolation, Z03 circular interpolation but in counterclockwise direction. So like this we have a lot of G codes. So all this code we will see one by one when we start doing the program. So you can see here G21 a metric unit, and now it is moved to G71. If you have to give cutter compensation, we have to use either 41 or 42, depends upon which side we are doing the machining. And if you have to cancel any cutter compensation already given by any program when you start any new program, is G40. Okay, and another one important is absolute dimensioning and incremental dimensioning. Okay, so this we already saw in section 2. Next is M codes. So these are few M codes: M00 program stop, M01 optional program stop, M02 program end, M3 spindle on clockwise, M04 spindle on counterclockwise, M05 spindle stop, M6 tool change. For coolant on and off we use M8 and M9. For clamping on and off we use M10 and 11, and program is stopped and reset to start using M30. So in CNC programming there are two types of program. One is called manual part programming. So in this manual part programming, what the operator writes a set of codes to define the program, and then the program is fed to the CNC controller. So you can see this is the CNC controller, or you can see it is the brain of CNC machine mounted near the on the it. So you can see this is the screen. Okay, and these are few controllers, X Y Z controller and some coding. So this coding, whatever programming can be done here also. So you have keyboard system here, so you can do coding here also, or you can do coding on your computer and then insert using RS code or USB or provided here. So here from that also you can insert the program. Next is computer assisted part programming. So this is the automatically the whatever the CNC program is generated depends upon your CAD model, and you, with respect to CAD model you have to do few more instruction to be given to that CAD modeling softwares. So currently available and very famous are these two, that is capstone and capsmill. So capstone is used for turning machines, CNC turn machines, and this for milling machine or vertical milling machine we use capsmill. This has purely softwares available for program CNC programming, and these two, that is Mastercam and SolidWorks, have a feature of writing CNC programs. So in this one you can draw a 3D model, either of them, and then you can generate the CNC code by giving additional information to that. Now before going to the actual program we have to go to some basics. So first we have to understand, more important is machine origin, program origin and part origin. So let's see one by one. Machine origin is a fixed point set by the machine tool builder. Usually it cannot be changed and any tool movement is measured from this point. The controller always remember tool distance from the machine origin. Next is the program origin. So program origin is point where the tool starts for its motion while executing a program and returns back to the end of the cycle. This can be at any point within the workspace of the tool which is sufficiently away from the part. So program origin is defined by the user. Next is part origin. Part origin can be set any point inside the machine electronic grid system. Establishing the part origin is also known as zero shift, work shift, floating zero or datum. Usually part origin needs to be defined for each new setup, and zero shifting allows the relocation of the part. So part origin nothing but a point on the workspace where you are defining 0, 0. So this we can understood using this simple diagram. So this is a simple diagram of lathe machine. So you can see these are the jaws on this. This is the part mounted on that one. So you can see uh, what is part origin. So I will define the center of this one at this part is the part origin. So from any dimension on this part will be defined from here. So anything this side z positive, anything this side z negative, anything going up, that is the depth of cut I'm giving, that is positive. When I'm coming outside, it is negative. Now this point slightly uh, away from the your workpiece is defined, that is the program origin. So when all the operation, let's say in this one turning operation is over, the tool will come to this position, that is a slightly safer position with respect to the workpiece, and this is the machine origin, which cannot be changed, and it is set by the manufacturer. So this is for lathe machine. Similarly, you can see on the next slide, uh, this is the machine origin for a milling machine, so very away. And then you can see on this part we have defined the part origin, okay, and then the program origin. So once, let's say in this one complete milling it is doing, it do all the milling, and then your tool will come to, milling cutter will come to at this position and stand. Now let's see a simple few tool motions. So let's see Z00. So Z0 is nothing but rapid transfer. So it is defined by like this: Z00 X X X Y Y Z Z. So what it means is X coordinates, Y coordinate, Z coordinate. So what happens? Suppose I'm moving from this point. This is my starting point. So what you have to give is G00. So it has to move in this at this point, that is X Y Z, rapidly. Okay, so there will be no operation in this in between. So directly whatever the speed is given, with that speed it will move to the next point. Now when we are doing any operation in between during this motion, we have to use linear interpolation, that is Z01. Same process, X Y and Z, and initially Z01. Now as we saw, Z01 is used for interpolation, which is linear in nature, so linear only. But if it is a circular thing, we have to use either Z02 or Z03. So Z02 is circular interpolation in clockwise direction. So when you see here, I can see, let's say I'm seeing from X in a plane of YZ. So you can see I'm doing in clockwise. So if any, this is my starting point, and let's say this is my end point, that is in clockwise, I'm doing any machining operation, I have to use Z02. But if it is in anti-clockwise direction, let's say in the same thing, I'm moving like this. So that is anti-clockwise direction, I have to use Z03, followed by X and Y coordinates, and I comma z or I comma k, depends upon the which plane you are working. Also we can use radius also instead of I and j. So more detail about this one we will see in next few sessions. So another more important parameter, especially in the milling operation, is the milling cutter compensation. It is defined by three G codes: G40, 41 and 42. So this is a very important function. Okay, so why it is needed? Let's see what is the need for giving a cutter compensation. So let's say this is my workpiece. Okay, so let's say this is my 0 comma 0. So I have defined origin here. Then if I move here, it is having a length of 100. So in, let's say this is my x direction, I'm moving 100. Okay, so this coordinate will be 100 comma 0. Let's say if I'm moving up, it is 0 comma 100. So this is y is changing, but x is remaining same. At this point it is 100 comma 100. Now let's say I got a drilling tool of, let's say, 10 millimeter dia. So this is the point at which the tool is standing, the blue color, so that is away from this one. And then I start doing the program. So that what happens if I give now here the center, if I don't give the tool compensation, and if I say move it, this tool to 0 comma 0 and start doing the machining like this straight, so you can see what will happen. So so you can see the when I not given any cutter compensation, what is happening, the center of the cutter is taken as the point, so it start moving from 0, and you can see a small amount of, let's say, 5 mm is go on cutting, so you will not get the required shape in this case. So what should happen, this cutter should be offset towards the left side depending upon what is its radius. So this is done by giving the cutter compensation. So you can see here, so this is with cutter compensation, so it will move here and it is getting offset by equal amount of radius. Now there are three G codes to give the cutter compensation. So first is G40, that is cutter compensation cancel. Then G41 cutter compensation left, G42 cutter compensation right. So you can say where I'm using G40, where the cutter compensation is cancelled. So whenever you are doing any new program on a milling machine, we have to initially give this command G40. Otherwise, what happens? Already existing given, that is the earlier program, if any cutter compensation is given, it will take into that, and then you may not get a required shape. So that's why I'm cancelling all the cutter compensation, and then I can define cutter compensation either G40, that is the cutter compensation left, G42 cutter compensation right. So we will see both 41 and 42 in more details. So let's, so this is this one. So this is G41, that is cutter compensation. So in G41 what happens is, let's say this is represented by this picture. So whatever you are seeing in the darker, this is the your workpiece. Okay, now cutter is coming from here, let's say, and it will go on cutting. So whatever it is cutting, the right side part is getting cut, and then it move follow the profile. So when you are seeing from your eye from the back side of the cutter, so your cutter is at the left side, and at the right side of your cutter, all cutting operations take place. At left side, it is free. So this is G41. Okay. Next is G42. So in see same, whatever I'm using workpiece. Okay, and let's say workpiece is going like this. It will go on cutting parts, then it follows. So you can see in this one, the tool is right side of the workpiece, and all left side part whatever along this one get cut. And when you are seeing from the at the back of the tool, you can see left side workpiece and right side is the tool. So this is G42. Now let's see the use of G41 and 42. So G40 is cancel all cutter compensation, you don't need it, and 41 is one compensation, and 42 is the another compensation. Okay, so let's go with 41. So again we are taking the same example of the workpiece. So you can see there is a workpiece of 100 comma 100. We have defined both zeros. Okay, 0 of 0, this is 0 100 100 100 100 0. So let's say go with the, now let's say I want to do cutting from like this. So what happens, the work, let's say your tool is here, it will come here, start cutting, goes like this, and then take a right turn, follow like this, and completely cut. So what is happening, the cutter is at the left side of the workpiece when I am seeing from the back, and the workpiece is right. Okay, so here which code we have to use, we have to use G41, because the cutter is when I'm seeing from the left sorry back side, the cutter is left side, and the right side there is a workpiece. But now in this case I am following like this, but instead of this one, if I follow let's say instead of clockwise path, if I follow anti-clockwise, so what will happen if I use the anti-clockwise, I cannot use the tool may be going like this. So you can see tool will come like this, then go to this 100, and like this it will follow. So in this case what happens, if I'm seeing from the back, the tool is right side. Okay, and the workpiece is left side. So in this case tool is right side, sorry, workpiece is right side, tool is left side, that is completely reverse. So that's why we have to use G42. Okay, so I'll explain you one more time. So we have the workpiece. So suppose you are taking a clockwise milling operation. Okay, so we start from 0 0, then move to 0 100 100 0, and then again to 0 comma 0. So that is clockwise motion. So what is happening when I'm doing any clockwise motion? Right, left side is the tool and right side is the workpiece. So we have to use G41. But suppose instead of clockwise I want to do anti-clockwise operation. So 0 0 I want, then I'll cut till 100 go by 100 comma 100, then 0 comma 100 and come to 0 0. So in this case anti-clockwise operation. So that's why the tool is at right side and left side is the workpiece where the cutting operation take place. So I have to use G40. Now this is applicable when we are using the outer cutting. But suppose we have to do inner cutting. What happens? So let's say, see this part. So this is the workpiece, and whatever the light blue color is, I have to do a simple milling operation inside. So let's say I got a one tool here. Okay, so tool brought it here. I'll go completely inside and do this operation. So what happens? Let's see here. I'm doing clockwise operation. Okay, but what happens? I have to see from the back side. Back side, if I see left side, I have to give there is a workpiece, and right side no cuttings is the tool. So cutting is happening at the left side. So that's why left side means I have to use G42. Similarly, so in this case I am going clockwise operation. Suppose instead of clockwise I go anti-clockwise. So what happens in this case? See, I got here right side is cutting. See from the back, the tool is left and this is right. Workpiece is right. Cutting operation is happening at right side, right? So this is G41. So you can see G41 when you're doing internal, it is become anti-clockwise wise, while G42 when you're doing internal any cutting, it becomes clockwise, which is totally reverse of what you saw in the when you're doing the outer part. So you can see when I'm doing any outer part, it is reverse. So G41 clockwise and G42 anti-clockwise. But when I'm doing here, it is completely reversed. Okay, so this is going clockwise, this is going anti-clockwise. So simple thing what you have to remember is see from the back side of the tool. Okay, if tool is left and right, cutting is happening G41. If tool is cutting and if the left side is the workpiece and the right side is the tool, you have to use G42. Okay, so I hope you have understood one of the important parameters, that is the cutter compensation in milling operation. So let's end this session. So if you have any questions, you can contact me at anilshirahatti@gmail.com, or you can call me on this number. Okay, I request everyone to subscribe my channel. Thank you.